All of us? Okay, so hi, my name's Alejandro, and we're Team Daga. This is Dalton, Genevieve, and Audrey. We're GEN 1400-50, first year engineers. So what we decided to make was we were going to create a headband resonator, which initially wanted to have vibrations of sound. Then we realized that it also transmitted music through your skull. So we tried to evolutionize it into making it into some sort of hearing aid with a band. And then Dalton will further explain how we did that through electricals.
Okay, hello everybody. Thank you for watching our presentation. I'm going to talk a little bit about some of the issues we had with it. First and foremost, the company we ordered these little transducers from, I don't know if you can see it, sent us the wrong parts. What those are, basically like a speaker, only instead of a cone that vibrates, it's a little plate. So when you stick it on your head, your skull vibrates and you hear it inside your head. As far as issues goes, the wires were never-endingly popping off, and we had to resolder and just go through a lot of, headache just to get it done, but it all worked out. We all learned a lot and we're better from it, and we came out with a great product.
Okay, so to explain how the transducers work, alright, so this is a transducer, and as Dalton said, it works kind of like a speaker, but it vibrates rather than transmitting sound. This is a diagram of how it works. So basically when the transducer is pressed on the skull near your ear, what happens is it sends, these are called bone conductor transducers, so the sound signal is sent as a vibration, and that's sent through your skull into your inner ear. It bypasses the outer ear, which is things like your eardrum, and it goes straight to your cochlea, which is your inner ear, and that transmits the vibration signal it translates it into music in your head. So the people around you can't hear this, but you can. And so there's a lot of potential future use for this, including a type of hearing aid. I mean, you could hear this underwater if you had it outfitted right, because it doesn't need air to transmit sound.
All right, so to speak a little bit about why this is such an amazing product is because Jen actually didn't hit on this yet, but basically there's a company in Europe that sells something similar, but it's actually a surgery, and it costs like $15,000 versus our headband that does close to the same thing for only less than $200, and if it was mass produced it would be even less expensive, which is why we plan to patent this. So basically, you explain?
Oh, how it works?
Well, I put it on.
Okay. Okay, so Audrey here is putting on our headband, and in this box we have our 2 amplifiers and our battery source and our auxiliary input. So what happens is when you plug in your music source into the aux cord, it goes into the transducers along with the into the amplifier along with the power source, which amplifies that music signal and sends it to the transducers. So when we play the music, the transducers will vibrate to the music, and it will send that signal as a vibration into her head, and none of us will be able to hear that, but she will.
Nice jam.
All right.
Right on.